Let me invite on the floor Dieter Schmastig from Graz University. Thanks to be here. Dieter ci introdurrà al tema delle realtà aumentate, di cui è probabilmente uno dei più grandi protagonisti sulla scena internazionale. I suoi lavori sono riconosciuti in tutto il mondo per avere soprattutto permesso a questa tecnologia di avanzare a livelli precedentemente mai visti. Il titolo della sua presentazione oggi sarà Augmented Reality in CultAR and Trend for Future Exploration. So vedremo anche quello che il futuro ci riserverà e credo che questa presentazione sarà molto eccitante. Thank you, Dieter, to be here with us, and good job.
Hello, thank you, Luciano, for the introduction. I would like to talk about the augmented reality part of the CultAR project, and I thought I'd make this short and sweet, not show you lots of technical details, but more the general directions, and also talk about some future trends maybe that go beyond what we have done in CultAR. But let me start with giving you a little bit of an intuition about augmented reality in general. So I think this is a strong trend that we are observing today. So you've probably come across it. Here you see some scenes from the experience that we've done in Padua. And obviously it's a mobile application that runs on your smartphone or tablet in the case of CultAR that overlays the real world with computer graphics. And we have been using tablets because they are the most widespread devices right now, but you have probably heard about Google Glass or Microsoft HoloLens. So head-worn displays are also up and coming alongside with all these wearable devices, and this is a really strong trend where more will be coming from major hardware manufacturers. Now, all of you also know Google Maps, so you know that you can retrieve information that is related to, let's say, the piazza on which you are currently standing, but that is a relatively coarse-grained thing. So if you retrieve Wikipedia articles related to your current GPS location, it will tell you everything about the vicinity. Whereas we are interested in superimposing precisely in time and space computer-generated information on top of the video feed of the real world. So we are really talking about high frame rates. If you have a camera that captures video with 30 frames per second, that's approximately what is going on today on standard devices, then we would like to overlay content that is accurate in the real world up to 1 centimeter and 1 degree of arc. So this is not like the coarse-grained GPS kind of georeferencing that we're seeing in conventional applications. And on top of that, it should work anywhere. It should work indoors and outdoors. For tourism, obviously primarily outdoors, which makes it relatively harder because you cannot rely on any pre-installed infrastructure. You don't even have a power supply and so on. And it should work with a really easy interface. This is why we're also working with the University of Padua on the human-computer interaction problems. You would like to have something that could be called point and shoot. Yeah? So without any user training, these apps should be understood by pretty much everybody. And augmented reality is not a new idea. It has actually come quite a long way. I've been doing this for almost 20 years now. However, in the past, we didn't have the hardware and the software to make that really working. So I dug in my video archive, and I'll show you a very crappy, low-resolution video from 2004, actually. So we built this first system in 2001, and a couple of years later, things looked like this. So already a head-mounted display, but you have to wear a laptop on your back. This is in Vienna. This is Charles Cathedral in Vienna. And here you see some cultural overlays like we did them back then, so you can get some information on the frescoes in the dome, for example, by just looking at them. But obviously with some very bulky hardware that is not really useful for everyday operation. That was more like, can we do it at all? And then things have moved on to smartphones. So the middle picture shows a relatively new commercial example. And in the future, we may maybe even see wearables like the Microsoft HoloLens in the picture here. What do we do with this type of system? Well, I would argue that there's an emerging new class of browser, the augmented reality browser, which gives you access to information that is situated, that is anchored to some object or concept or place in the real world. So by just looking at an object of interest or pointing with your smartphone, you can retrieve that information. And in that sense, everybody knows how to use a web browser. So what do you do with a web browser? Well, it's a general purpose tool. You give it an internet address and it gives you information from there. Now you point your AR browser at an object and it gives you information related to that object. And that is a very lightweight interaction. If you want to use a web browser, even on a mobile phone, you still have to type in the internet address and you have to stop everything that you're doing. Most people will not be able to keep walking or have a conversation while they're using a web browser. Here it should happen more or less spontaneously as a byproduct of looking or pointing at things. Obviously the information doesn't only have to come from curated sources like cultural heritage databases, but it could also come from social media. It's the same thing as we see with web. Other people could give you information like, look, this place has really good ice cream. This is the kind of information that you could get there. And there's a lot of potential for such augmented reality browsers. I've listed a number of application examples here. Tourist guides come in the first place because they are relevant in the CultAR project, but there are many other things like virtual sticky notes or advertising or repair procedures, training, instruction, fitness instruction, and things that you might not have in mind first. So Italy is the land of the Panini stickers for the soccer championship. So I'm sure my son would love this if you could turn your soccer sticker collectible book into an animated version that shows you all the great players. If you are interested more in a professional kind of application, then for example, if there's construction going on, there's always the danger that some caterpillar driver digs up the ground and breaks the power line that is underneath, and there's actually a law that requires that they have maps of the environment, and this can still go wrong. And with the right kind of tool, the whole issue of street surveying and inspecting underground infrastructure can become a very different kind of thing. So here you see not only the inspection of where is the power line, so I don't disrupt it inadvertently, but you can also do some replanning of the power line. So they're now going to make some basically computer-aided design operations directly in the real world, like where to dig is marked up in green. No spray cans anymore, you do it on the computer. Yes, so this has quite a few technical challenges. One of the biggest is outdoor localization. You need to find out where you are if you use the mobile device, and the way you can do that is you capture the video from the camera of the device and compare it to a big database that contains a 3D model of the city. And if you have a match, then you found the place where you're standing. So what does this 3D model look like? Well, it's also made from lots and lots of images, but then they are converted into a big point cloud. So maybe some of you recognize this location. obviously taken from the CultAR project here. This is the kind of database that we are using to compare the video to. Then if you want to find out where you are, it would give you this kind of impression. This is an example that we've done at my hometown in Graz. Now that would be a terrible example because nobody wants these advertising billboards stuck to the facades like that. But you see that you get very nice, what we call registration. That is the billboards really look as if they are glued to the facades in this place. This comes from this image-based recognition where we build a model of the place up front and then we do this video matching. So with this kind of technology that runs on standard tablets now, you can get the technology going for augmented reality. And now we can move forward to presenting the content. And there another issue pops up. You probably know that from long and complicated web pages, there can be an overflow of information. The same happens if you now anchor information in the real world. So you give some request, but there's too much information and you only end up with a big clutter. You can't make any sense of it. And obviously, by making some more specific selection, you can bring that down to a smaller set of data points, and that is maybe easier to handle. But you still need some kind of clever arrangement of the information because you're trying to look at the video of the real world at the same time. And if you occlude everything from the video, all the pixels of the video with some text or whatever information you have, then you're not going to get the connection going. So the problem is what is called view management, which is basically a layout problem. And here you see on the left-hand side what happens even if you have an algorithm that already avoids the object, in this case the head model. So that's not outdoors, that's obviously an indoors scenario, anatomical example. Even if the labels avoid the head, it's still not working if the user is moving. And on the right-hand side, you see how we have developed a technique that is basically doing that in a more clever way, that is not only avoiding the objects that you do not want occluded, but also doing it consistently in 3D. So you get some impression as if somebody had put some, well, flags or poles into the head. And that makes a much nicer impression if the person is actually moving around. And we're also trying to use that outdoors, although outdoors you have much less control over the situation and that it's relatively challenging. So these are some of the main things that we have done for the CultAR project. I don't want to take too much of your time, but I thought I'd talk maybe about one or two additional examples. So let's start with some obvious thing, namely the social sharing of annotations. This is something that we've already started in CultAR, but bringing it to a level where it can really be deployed on a, a professional scale is much more work and also requires more resources and infrastructure. But in principle, it's relatively easy. If you have this system that can deliver geolocated, geo-registered content via augmented reality, then you can also let people input that information. So in this example here, a guy called Peter is creating some new annotation, like I like this ice cream shop. And then you store it on a server, and then his girlfriend Mary can download that when she comes to the same location and experience this information. And here's a little video clip that shows how this is going on. So here's an augmented reality browser, very simple one. And now the user is clicking a button and is adding an additional annotation, in this case the name of the building. This is then registered in the database alongside with the 3D model that we have of that building, and therefore other people can retrieve it at a later point in time. I think this will become important as a new kind of social media. If the same people who are using Facebook to document everything that they're doing and already cross-referencing it with Google Maps or some GPS location will be interested in that kind of thing. And another aspect of social media is situated video. So there's a lot of selfie videos going on now, and also people who do sports or who do all kinds of things document what they're doing on video and then are sharing those videos. And you can now register videos to the location as a new type of medium. So not only can you input some text that is a textual description of an environment, but you can also show what the person is doing there. For example, a skateboarder has been pre-recorded here and is now registered again to the environment. So for example, people could compare how good their skateboarding in a particular location is. And you can walk around and look at that from all angles. In this case, the mobile phone was set up on a tripod, but in principle, you can do lots of these effects that you may know from sports channels now in the real world. And we think that will be an exciting application that can also relate to a place. Yes, and if you want to go even deeper into what people are doing, then you can even go to physical instructions, and that has also some nice applications. So some applications might be, more professional, like teaching somebody how to solder, and we can extract that kind of motion directly from video and teach a person how to do it, or I don't know, to learn how to do your makeup. In this case. But if you try to get involved in some more cultural activities like cooking, for example, then there may be more complex motions involved. So here's instructions how to not cut up your fingers along with the cucumber. But I'm actually waiting for this final example in this video clip. Everybody knows that if you go to a foreign place, there will often be these entertainment nights where you learn how to dance. In this case, for example, German folk dancing. That can be relatively challenging. That was short. Let's see if I have some more. And you can learn the motions that are extracted from some video and that allow you to deal with these physical skills that you need to acquire there. And we've actually tested that, and it seems to be fairly effective, presenting motions from a first-person perspective, in particular with a head-worn display on. All right. Yes. So let me wrap it up. I think AR will become an important new medium. Tourism is an important field of application, and we've made some really big steps forward in the CultAR project in bringing that into the real world. But obviously, tourism is only one form of activity, and augmented reality could also be used for many, many more activities. An interesting aspect, I think, is that if more people have this technology available and have access to the devices, then augmented reality can become also a social medium. And then this whole process of being outdoors, being a tourist, and social sharing with your friends that are or are not in the same place will become much, much more richer through this new technology. That brings me to the end, and I'll be happy to take your questions.
No question. I think we will have a question later. Thanks, Dieter, again for this very inspiring presentation and to introduce us to the future of augmented reality, not only what we did inside the project. It's now time for Aalto University. Antti Nurminen, the coordinator, will now introduce us to his specific team of research. Antti ci introdurrà al suo specifico tema di ricerca, prima ci ha presentato il progetto in generale, ma oltre che coordinatore del progetto, Antti ha lavorato a una specifica parte di sviluppo, in particolare alla realizzazione delle mappe 3D. Quindi il titolo del suo intervento sarà 3D in CultAR and Trends for Future Exploitation. Thank you, Antti.
Thank you. Okay, so my topic is 3D maps. If you think about creating an expression of your environment visually, how would you do it? Humans are really accustomed to seeing through their eyes, so you would like probably do a drawing of your environment. But if you want to have a larger environment, how would you do that drawing if you cannot fly? It becomes quite a challenge how to represent your environment in larger scale or even smaller scale. So already 2000 years ago they were thinking about how to make it happen, and they realized that there are two parts. You do measurements of your environment and then you render it. And the measuring part itself was considered to be something of a real science of its own without really technological tools for that. And they created a global coordinate system for that. And if you look at map data 2000 years ago and map data of today, it's the same more or less. Same latitude and longitude already there. And now it's a little bit more accurate. And then again, you can render that same data in different manners. For example, 2000 years ago, the Greeks didn't really like to put any decorations to their maps, and later on these kind of Ptolemaic maps are familiar because of the decorations, but they themselves didn't like it at all. But there's always some liberties how you use your map data and how you create your representations. Romans tried to address that problem of scale. They made a very accurate map of the Rome itself, hacked that on marble, 18 by 13 meters. It's not very good for mobile use when just that one fragment on the left weighs about 70 kilograms. So you can't carry that kind of 18 by 13 meters marble block around with you. Well, okay, that was for small scale. What about if you travel within the Roman Empire and you have all the Roman roads there? You can render that Roman road dataset into, for example, a parchment, which was a suitable medium of the day. Then you have this tabula Peutingeriana, which is like 7 meters long, 34 centimeters wide. Again, this is not something you can create for any tourist in the Roman Empire. Very special rendering of the Roman road network. And you wouldn't use that normally as your carry-on mobile map. So instead, if you know where you're going, if you're going to Rome, for example, you create just a list of towns, an itinerary. So on the right-hand side, you have the real Roman mobile map, which is an itinerary, a list of cities through which you would travel to reach Rome. Then again, you have the problem of scale. Now you have to rely on the road map, road data, that you actually find these cities on your way, but no way you could have the whole Roman Empire hacked in marble and carrying with you. It would be the size of the Rome. So it was a problem, it still is. However, 2000 years later, we realized that maybe we have these nice electronic devices and we can finally render our environment in a similar manner as we are used to, in a three-dimensional realistic manner, exactly as it is. So Professor Rakkolainen from Tampere, Finland, tried it first on the good old PDA devices, if any of you remember those devices from 15 years ago. They created a city model of Tampere and tried to render it. No way you couldn't fit it into the memory. So they cut away most of the city from the nice model and had a small piece remaining, and that they were able to render once every 8 seconds. And they thought that maybe in future it will become better. So now, ladies and gentlemen, we are in the future and we have tablets. So we can actually render that nice city of Tampere or the city of Padua on our tablets. However, again, we are faced with the problem of getting that data set, how to render the data set. For Padua, we were really happy to receive a very accurate CAD model of Palazzo della Ragione, created by University of Venice, which we then took and simplified and textured and made it into part of our small city model. But this is still something that's very, very resource demanding, and humans have to create such models. We really hope that automatic means would make such modeling possible. Right now, automatic means are available, but not at this level of quality. For CultAR, we collaborated with Community Padua in creating a part of the city, given our limited resources, and we're able to create a few areas of the city center which we can use now for the project purposes. So we started up with the CAD model, and then we created these quite simple blocks which we textured with digital photographs which were made by CDP. We can use now these 3D models of Padua to travel around, navigate in there, but also to annotate. So 3D maps are very good for creating three-dimensional annotations. The problem of that is that current data sets are still very traditional. You have latitude and longitude like 2,000 years ago. Nothing has changed there. And now you actually would like to pin those points of interest to the actual places, the actual positions in our environment. We created a specific tool where we take in the cultural content of Padua and place them into the model so that we can actually have them there. And again, this is something that we have to do manually right now because the existing data sets, cultural data sets of urban areas, they are not really intended for 3D use yet. It's interesting that we actually can do it very accurately. So one specific feature of these higher quality 3D models is that you can really pinpoint your target, your point of interest, to the actual visual position. So if you compare this to any usual 2D map, you couldn't even find out the vertical position on a facade of a building where this actual target is. But with the 3D model, this is possible. What I would see for near future of 3D maps is that we would start having more dynamic maps. Instead of just annotating our models with static information, we would use live data, real data emerging from the actual environment, sensor data, people moving around, vehicles moving around, and use a 3D model or kind of a data model that allows management of this kind of live data. In a simple case, for example, if we measure the quality of water from the environment, instead of providing some numbers on oxygen level or murkiness or conductiveness or whatever somebody wants to see, we can visualize that data immediately on top of the 3D model. We can render, for example, our environment based on the sensor data. So our 3D model becomes more dynamic and more closer to the reality. We can, of course, emphasize information. Here on the top, you see water quality rendered based on the murkiness, for example. That means how much you have dirt in the water. If it's very clear, it's reflecting the sky. If it's kind of murky, which has a lot of dirt in it, it doesn't reflect. Very simple and should be easy to understand for people. Or we can color code temperature. If it's red, it's hot. If it's blue, it's cool, whatever. So the 3D model becomes more dynamic with sensor data from environment. In another case, we have a tracking system for this. Again, it's the city of Tampere, so this is actually the 15-year-old model they used there. And the McDonald's is still there for the next 1 or 2 weeks. It was the first one in Finland. It will disappear, so now we had to make a change to the city model. We track anyway in that city the entire fleet of public transportation and can visualize it also in the 3D model. I see this is one direction of 3D models where it's not just the static model, but you have to find ways to update it and update it really fast. The Romans probably had very tough problems in updating their marble map. If they tried to have something moving on the marble map, the refresh rate would be a few years, I think. Here we can hope to get something like 30 Hertz. One direction is, of course, which is very close to 3D maps, is the augmented reality that Professor Schmalstig just described. We are discussing the same thing. We have the user is looking at the world through a 3D model or through the video stream coming from it on the tablet device. And we can combine our 3D model and the real world. Professor Schmalstig just described how they create these point clouds, a representation of the environment. And both AR and 3D need to have the same registered understanding of the three-dimensional space. So, for example, here we have a small 3D model, and then we have automatically created a point cloud. And they, of course, should be in the same coordinate system. So once we do registration between these two different types of models, then we can have, hopefully, a combination of them. Let's see if I can make it run. Yes. So Palazzo della Ragione, reality, augmented reality, 3D model, back to augmented reality, and back to reality. So this is one goal of the project, to combine these two technologies smoothly together. Okay. One small feature we have in the CultAR system is dealing with the visibility. For augmented reality system, if we populate our city with dozens of points of interest, it's difficult for the augmented reality system to know which ones are actually visible to the user. For human, it's of course really intuitive. Okay, I can see this cafe, it's there. But for a set of points of interest in a database, you can do a search for proximity within 100 meters, but they can still be behind buildings. And if you overlay in front of your video stream, it could be confusing for the user. User will see the cafe label in front of the building, but it's actually behind the building. This is really confusing. So in CultAR, we can do a visibility culling process online, where we are still in the augmented reality mode, for example, but we use the 3D model on the background to do the occlusion test, if this cafe is actually visible to me now, or is it behind the building. So we use our 3D model in this manner, which benefits the augmented reality. So we have this nice harmony of these two technologies and combine them, take the best parts of each, and can users choose what they wish. I think I'm nearing at the end. Just want to say that 3D is now becoming really interesting feature everywhere. If you have 3D data, you can render it on the computer display, or you can print it out. So one funny thing now is that you can, for example, print out the star systems. And for humans, just to have a tactile version of a star system can be more expressive than actually the rendering on the screen. So these researchers, they found new features from this Eta Carinae system just because they printed out different phases of that with 3D printers. Just a leap from our 3D maps to something completely different. Thank you.
Thank you. Thank you, Antti, for this very clear presentation. Grazie per questa presentazione. We will have a question later, as usual. There's now time for Anne Morrison. Here he is. From Aalborg University. Anne is a scientist, a designer, a performer. She did a great job inside CultAR, both with something developed in Aalborg, but also as designer of the vest that you see on the mannequin. And the title of her presentation will be Wearables in CultAR and Trend for Future Exploitation. Thanks, Anne, to be here and to introduce us to your product.
Thank you very much. Okay, hello everyone, and thank you for the lovely introduction, Luciano. We are a small lab in Aalborg University, and we've been working directly with wearables in this project. Of course, at the moment, there's a huge market out there with a lot of gadgets, particularly around fitness and assistive technologies. For this project, we've concentrated on navigation assistance, responding to feedback from points of interest in the environment, both here and in Aalborg, the second site. And we've been working with a wearable vibrotactile vest, which we see up on the stage here, a 3D audio solution, and a haptic glove, which will be covered by University of Helsinki. So one of the main priorities of the work we have is to calm and relax people, to activate them, to guide them in the environment, to inform them and warn participants, and that it's used for mobile navigation in an outdoor environment. Of course, it's a challenge to just work with vibrotactile information. It's also a challenge working with the body. We started with the idea that we would have a one-size-fits-all vest. It's quite a challenge in itself. We needed the vest to fit tightly to all curves of the body, and of course all bodies are very different, longer in certain parts and wider in others, with bigger and smaller curves. We wanted to help people navigate. We needed that it felt good to wear, that it wasn't restrictive, that it assisted with hands-free interaction in the environment. After the presentations today, we'll have demonstrations, so please, I invite you to come and try. We have 2 vests running, and there's a variety of versions. So we have the vests where you can have full sensations, calming, activating, and navigation, or navigation with audio, and navigation solo. So we would really like you to come and try these. It's very different from just looking at them, and very different from just thinking about vibrotactile on the body as some kind of buzzing that happens. It's a very full sensation. We've had various versions of the vest, and I'll run through these quite quickly. First, we started with a very soft cotton kimono that could be adjusted. We have an internal harness, so we could slide things along and adjust them on the body relatively easily. And what we see here is with the dots on the person where the actuators are actually located. The idea being that, for example, the patterns that we would have would emulate natural touch. So we have the idea of running the hand up or down the back to help calm, or around the waist to help also a feel-good sensation. Here we have people wearing it in environment in Aalborg, and this is this early second iteration of the vest with a padded outer shell of different sizes that would make sure that the actuator stayed close to the body. We had a variety of locations on the body and a variety of calming, feel-good, activating, and navigation patterns. Also a warning information pattern on the solar plexus, which would really instruct people to stop if there was some kind of emergency. This was part of a small opening event in Aalborg, and we addressed the site there, which was an old industrial area, which is being refurbished into a cultural precinct. The park itself was situated here, and we needed to address the aesthetics here of a site that's also beside the Utzon Centre, the architect who's also designed the Sydney Opera House, but also to try to ensure that people stayed longer in the park rather than just using it as a pass-through space. So we built an environment that was responsive to the vest, but also responsive to the needs of the passers-by. This is an interactive humming wall. It does literally hum. I'll show you in a video shortly. And we had various zones of the wall that were responsive when you were wearing a vest, differently to a passerby experience. It worked as a kind of a musical instrument. We had lots of people participating in pairs at a series of trials over 5 weeks, and I'll show you some of those kinds of interactions. Hopefully we're not too loud. Okay. Oh, we have sound issue again.
All right. That one? I do it. Yeah. It's like wearing one of those chairs. Yes. Okay, and again. And again. You can come along if you like.
Oh, I like that.
Okay, so new pattern coming.
Yeah. Oh, okay.
Oh.
It's actually releasing something.
One more of those.
Yes. Yeah, but it has the same pace.
No, okay.
Yeah, there's no difference if you're fast or slow. Oh, I'm getting this. Ooh, it's down here.
Bring that up, bring that up.
Going up. Maybe I'm dead.
No, it's not going up. You have to go up. Too fit. It's too fit. Yeah. Sometimes.
Come on, Hart! You can do it.
Ah, yes. Here we have it.
Are we going up?
Yeah, going up.
Okay, so you can see it also responded to physiological data from the wearer with a heart rate and a breath rate being shown at the wall, at various sites of the wall. We looked at what people responded to, and we had a very nice response to up and down patterns of the back and around the waist. And of course, stop and the activation patterns were not so warmly received, which is quite sensible, really, as they were not meant to be so pleasant. However, we wanted to work with that, and we looked at some of the confusion people felt, for example, with navigation. If we had, as you would with an elder, you would have a hand on the back and the waist, but when you have vibrotactile sensations in two parts of the body, it's confusing for the person wearing the vest. So we needed to work with that. We updated our harness firmware from this so that we had a much less intensive running situation, and we also looked at modularizing the vest. So there was less need for the long fitting sessions we'd had with this vest, and also that we could make a modular system for combining patterns differently. So you might have calming and warning patterns with a navigation, but you might have feel good and activation for another version. So this version we made up was looking at threading the electronics between three soft layers of material, and that would be domed together and fit on various sizes of bodies. We ran some lab tests here and found that we could actually work with the back in a much more substantial way than we thought if we changed the ratio of duration of patterns to the overlap. So if there was a 1:2 ratio, it was calming, but if it was, for example, 500 milliseconds with a 400 overlap between the millisecond overlap between the next actuator kicking in, it was much more activating for the person. And that was information that we needed to have in order to make sure that we could keep redesigning the patterns and working with those. At a certain point, we realized that one size fits all was just too hard, mostly in terms of the fitting. So we brought in some vests of various sizes, and these are what you see today, or versions of this are what you see today here. With a zip-up vest, with Velcro that you can position differently, etc., and making up we have a series of holders for the actuators so that the vibration is felt, but the sound of the vibration is dampened to some extent. And we also looked at modularizing the boards as well. So we broke down those aspects so that there was less weight on various parts of the body, etc. So, yeah. Okay, and this is how it looks in its sort of final laid out. And small, medium, and large, or we actually have extra small and extra large as well. And over the top of that, we place a stretchable, which makes sure that it hugs tightly to the body, and we have some other Velcro which can add to make sure that, for example, in the small of the back, that is held firmly against the body. I'll just show you a short video here of some corridor testing of the... And another one set in the courtyard in Aalborg, where we're testing it with a basic version of the CultAR app to make sure it's automatically maneuvering the person in the environment. So as you can see, some people are very literal when they get turned, and yeah, that was one of the things we were looking at. How close to the turn does it need to be before you give the instruction there, for the navigation instruction from the vibrotactile. We also are looking at 3D audio, and one of the things that we needed to look at was distances to points of interest in the environment, and how to make it clear to a person how far or near they were to a point of interest, with a 3D sound environment that we developed. And we have a very responsive audio, 3D audio system, which would really like you to come and test with us. We have custom created audio clips that are generated also within our larger CultAR app database, showing points of interest with their titles and descriptions, etc. So you also have the beacon telling you where you are and location to the point of interest you're heading towards, and then information on that actual point of interest coming through your headphones. So again, I'd like to invite you to the demonstration afterwards. We'll leave from here, so it will be an organized, orchestrated thing, and there are the more intensive, full potential with all the different sensations, activating, calming, navigation, and warning information, or the guided monitor using the audio, or just with the vibrotactile, or just vibrotactile itself. And that's a system that will be navigating you within Padua environment. So please come and join us. Okay. Thank you.
Thank you, Anne. Thank you very much. And thanks also for the great collaboration among our university. And thank also to Walter and Jack that visit our lab. It was a great experience for all of us. Come avete capito, poi più tardi è anche possibile sperimentare le tecnologie, ci saranno alcuni demo, sarà possibile vedere la veste e il guanto in funzione, quindi dal buffet in poi chi volesse testare e provare queste tecnologie sarà abilitato a farlo. Grazie ancora, Anne. Thanks again for your very inspiring presentation.